Sorry about that. So the name of our project is Stop and Go Station, and I'm Scott Terhorst, and this is Linton Zimmerer. The requirements and specs for our design was to create a simulated four-way traffic intersection using photoresistors. And we have 4 lanes entering the intersection, as you can see, and we have 1 LED set for each lane. And the light signals will respond to automobile detection by these photoresistors, and it operates similarly to a traditional intersection. And furthermore, we have just little compass directionals so that we can keep track of each lane. And furthermore, the parallel lanes, so like the north lane and the south lane, if you block one of the photoresistors indicating that an automobile is there waiting to pass through the intersection, then both of the signals will turn green and then yellow. This is our system block diagram. The sensing unit is comprised of the photoresistors creating a voltage divider with 10K ohm resistors. And what happens with photoresistors is if you're blocking, or the incident light is proportional to the resistance of the photoresistor. So when you block the light incident on the photoresistor, then you'll get a lower voltage at the voltage divider. And we have that going into the ADC on our Arduino. And at that point, at the Arduino, we specified a threshold voltage such that it will output the proper signals to our LED lines. As for the design overview, like I was saying about our detection stage, it's just a voltage divider across a photoresistor in series with 10K, and then we input this to the ADC on the Arduino. And actually what we did to take care of all 4 lanes is we used the MUX for the ADC, and what we do is we just have the detection cycle that begins with north, moves to east, and then south, and then west.
So the lights were pretty simple. These lights were actually in series, the red lights and the yellow. So they will always agree, as you can see with, so this would be the red.
And then for our integration and testing, we pulled most of the software from our Project 3. And for Project 3, what we had was pretty much one set, or I guess it's 2 sets of LEDs, but they would be running in parallel such that their operation was exactly the same. And we didn't have to account for any of the MUX or just the other directions. We also used a distance measuring sensing unit, which is just the photo emitter and
replace the photoresistors that we're using on this project.
And so for Project 4, we pretty much expanded our software and our hardware to include 4 LEDs and make it operate for 4 lanes. And that's about it.
Can you expand again why what the difficulty was with the distance measuring sensor unit?
We were trying to use photo diodes for that part, but they weren't working for whatever reason, so we ended up using the distance measuring device just because it was something we had access to. But I ordered the photoresistors and they were fine, so they're a lot smaller, so we preferred them.
Any other questions? All right, then we'll go ahead and demo it. And if anybody wants, they can just come up here so it's a little easier to see the LEDs.
You gonna make Fermi noises?
Say what?
You gonna make Fermi noises?
It does not make noises, unfortunately.
Maybe next.
You can demonstrate it, Nathan.
Alright, so as you can see, all the lights are off. Some cars are there. Let's look at this car here. And yeah.
Nice.
Yep.
And then once the car passes through the intersection.
Of course, if the car stays there, we want to turn it off so that the other line has a chance to go.
Oh, you don't get very long to get through that intersection on that yellow light, huh?
Yeah, the timing could be modified.
I think it makes sense. You're accelerating a lot less mass than a normal car.
The engine's a lot smaller too, I would suspect.
Yeah, I think so.
So if you guys want to see the bottom, here's all the things we have going on.
Nice.
The north
Some of
and the west side.